Okay, today you're going to be learning about 9.3. We're going to be talking about the geometric mean. The altitude of a triangle and similar figures are things that you should already know. First part of it is you're going to see right triangles like this figure here. And there's actually 3 total triangles here that we're going to be comparing. We have the largest triangle, which is ABC. We have the medium-sized triangle, which is ACD, and then we have the smallest triangle, which is CDB. Okay, so that's 3 triangles that we're going to be dealing with when we're trying to find the similarity statements. Okay, so theorem 9.6, right triangle similarity theorem. If the altitude is drawn to the hypotenuse of a right triangle, then the 2 triangles are similar to the original triangle and to each other. Okay, so with that said, let's go ahead and try example 1. It says identify the similar triangles in the diagram. Alright, so the way I would approach this problem, some of you can actually just see the triangles the way they are and write the similarity statements, which is fine. But me, I'm a visual person, so I need to actually redraw all 3 triangles to where they're right side up. So I'm going to start with the largest triangle. Okay, and I'm going to start with R, and I'm going to put it up at the top. And I'm going to go down to my right angle. Okay, so that's R, and that's T. And then I'm going to go up to S. So on my picture, I'm going to go to S. And now I have my right triangle right side up. Okay. So I'm always going to start with the tip. Now I'm going to go to the medium. Okay. Well, if I look at the medium, that's going to be this red triangle here. I'm going to start at the tip, which is R. And if I go to my right angle, that would be U. So R, U, and then it goes to T. Okay. And then I'm going to look at my smallest triangle. I'm going to put it here in green. So I'm going to start with my hypotenuse and my longest leg, or my altitude, and that starts with my T. And then I'm going to go to my right angle, which is at U. And then I'm going to go out to S, because it's along my short leg. Okay, now that I've written all 3 triangles and redrawn them to where they're upright, my similarity statements are going to be RTS is similar to, I went RTS, so on the medium I'm going to go triangle RUT, and then on the last one I'm going to go from T U to S is similar to triangle T U S. And that's how you do the first example. Alright, so example number 2, modeling with mathematics. A roof has a cross section that is a right triangle, and the diagram shows the approximate dimensions of this cross section. Find the height of the roof. Okay, so the way you can approach this problem is seeing that we do have similar triangles here. And so we can actually draw my 3 pictures and label what we know. Okay, so on my small triangle, I'm going to label it in red. Okay, my total height, so my altitude is H. The small part of my leg, we don't know. And then we have our hypotenuse, which is 3.1. Okay, and then let's move on to the medium triangle, which is ZYW. It looks like you always know which one's your hypotenuse is because it's across from the right angle. Okay, so 5.5 is across from the right angle, so it's my hypotenuse. And I know that the bottom is H, because it's my short leg. And I know that this whole side here is 6.3, but we don't necessarily know how long this is. Okay, so we're just going to leave it blank. And then on a large triangle, what's nice is that I actually already know all three sides. So first I want to identify my hypotenuse, which is across from my right angle, which is 6.3. I know that my short leg is 3.1, and I know that my longer leg is 5.5. Okay, and just looking here, I should be able to set up a proportion between either my small and large triangle or my medium and large triangle to find out what h is. Okay, so I'm just going to use my medium and large. So I'm going to put 5.5 over h. I'm going to set that equal to 6.3 over 3.1. Okay, so I went 5.5 to h, 6.3 to 3.1. And then I'm going to do cross multiplication. Okay, so I'm going to get 5.5 times 3.1, and that's going to equal 6.3 h. 5.5 times 3.1 is 17.05, and that's equal to 6.3 h. And then you divide by 6.3 on both sides, so you get your height to be about 2.7. And I'm putting about is because there's actually a very long decimal, and so it's just an approximation. And that would be meters. Next thing we're going to talk about is the actual geometric mean of two positive numbers, a and b. Is the positive number x that satisfies a over x is equal to x over b, so that x squared is equal to a times b, and x is equal to the square root of a times b. Now, I know that's a lot of variables, so let's try an example. Okay, example 3, it says find the geometric mean between 24 and 48. So we're going to use the formula x squared equals a times b. And in this case, a is going to be 24 and b is going to be 48. Okay, so I'm going to plug those in accordingly. Okay, and I'm going to get x squared is equal to 24 times 48. Okay, well 24 times 48 is 1,152. So the geometric mean is just x, so I'm going to take the square root of both sides and get x to be 33.9. That's if you're allowed to use a calculator. However, more than likely you're going to have to put it in simplest radical form. Okay, so simplest radical form, you have to think, okay, what multiplies to get 1,152? And I know this can split up into 24 and 48. Okay, I also know that 24 can be split up into 6 and 4, and we can go farther into 3 and 2. 4 is 2 and 2. 48 is 24 and 2. 24 goes into 6 and 4, and then we have 3 and 2 again, and then 2 and 2. You look at your partners, so I have a 2 here, 2 here. I have 2 2s. I have another couple 2s, and then I also have the 3s. Okay. So on the first pair of 3s, one makes it out, one is crossed out. Okay. So we took care of those. We have a pair of 2s, one gets crossed out. We have another pair of 2s, so one gets crossed out. And then on the last pair, we have another pair of 2s. And then we have this one lonely guy that didn't have a partner, so he's stuck inside the house. Okay. So 3 times 2 times 2 times 2. 3 times 2 is 6, times 2 is 12, times 2 is 24. So x is actually 24 square roots of 2, and this would be the exact answer, which is what we're looking for. Okay, that brings us to a couple theorems. We have the geometric mean, or the altitude theorem. In a right triangle, the altitude from right angle to the hypotenuse divides the hypotenuse into two different segments. Okay, so if you take a look at my picture, our altitude, it's squared, is going to be equal to the pieces of my hypotenuse multiplied together. Okay, and then we have the geometric mean leg theorem, which in a right triangle, the altitude from the right angle to the hypotenuse divides the hypotenuse into two segments. That's the same thing as the previous theorem. However, the length of each leg of the right triangle is equal to the geometric mean of the lengths of the hypotenuse and the segment of the hypotenuse that is adjacent to the leg. So the way I remember it is, if I have my long leg, it's squared. It's going to be equal to the long piece of my hypotenuse times the whole thing. Okay, and that's what it says here. And then my short leg squared is going to be equal to the short part of my hypotenuse times the whole thing. Okay, so just a recap on the altitude. Okay, altitude squared is equal to the pieces of my hypotenuse multiplied together. On the leg theorem, my long leg is equal to my long piece of my hypotenuse times the whole thing. And the short leg is going to be squared is going to be equal to the short piece times the whole thing. Okay, I know that might be a little confusing, but let's try an example. Okay, so in A, here we have my altitude. So I know that my altitude squared is going to be equal to my two pieces multiplied together, so 6 times 3. Okay, so x squared is equal to 18, and if I take the square root of both sides, I get the square root of 18, and you have to think to yourself, okay, is 18 in simple as radical form? Well, it's not. So you have to reduce it. 9 and 2, 3 and 3. 3's are partners. So x, we have 1 breaks out of jail, so 3 is left. One of them dies, so he's not written. And then we have this one guy who's still stuck in jail because he didn't have a partner. So this altitude is actually 3 times the square root of 2. Alright, looking at B, now we have my short leg. So I know that my short leg squared is going to be equal to the short piece of my hypotenuse times my whole hypotenuse. Well, my whole hypotenuse is 5 plus 2, which is 7. So it's going to be 2 times 7. Okay, so now I get y squared is equal to 14. Square root both sides. I get y is the square root of 14. Okay, and then you have to reduce this. This reduces to 2 and 7. Well, the thing is, they don't have a partner, so that is in simplest radical form. Y is the square root of 14. Actually, no, I take that back. I think you can actually just kidding. No, that is right. Okay, so y is the square root of 14 is your answer. Okay, and for our last example, using indirect measurement, you find the cost of installing a rock wall in your school gymnasium. You need to find the height of the gym wall. You use cardboard square to line up the top and the bottom of the wall gym. Your friend measures the vertical distance from the ground to your eye and the horizontal distance from you to the gym wall. Approximate the height of the gym wall. Okay, so we actually see that we have our 3 triangles here, and we can actually use the geometric mean to find out what W is. Well, I have my altitude here, and I know that my altitude squared is going to equal to my 2 pieces of my hypotenuse multiplied together. Okay, so now I have it set up. So 8.5 squared is 72.25, and that's equal to 5W. Divide by 5 on both sides. W equals 14.45 feet, and it's not looking for what W is. It's asking for the whole height of the wall, so you have to take 14.45 plus 5 to get your answer, which is 19.45 feet. Okay. I know geometric mean might be a little confusing, but don't give up. And of course, you're going to do more examples in class. And be sure to ask questions. Thank you for listening to my video.